Hey everybody, my name is JJ Asghar. I'm a developer advocate for IBM Cloud. I really have the email address of awesome@ibm.com, and you can find me at JJ Asghar. Perfect. So let's talk about some building blocks first. Obviously, in 5 minutes, I'm not going to tell you everything you need to know about Kubernetes because that's just Herculean. So we're going to start very simply with building blocks. By the way, I literally wrote this talk just before this, so hopefully everything's going to be okay. I haven't practiced it. Everything begins with a pod or a container. So as you can see, there's multiple different types of technology. There's Podman, there's Docker. I got yelled at by marketing. I'm not allowed to use the Docker logo. There are multiple, okay. Wow, this is worse than I thought it was. Now when you start building up more containers, you need a way to orchestrate it, and that's where Kubernetes comes in. All Kubernetes is just an orchestrator. That's all it does. Minor quarterly releases, no long-term support. Go to landscape.cncf.io, have a heart attack. Next, go to OpenShift is an actual enterprise offering of Kubernetes, right, where you can actually put your business on it. It's very opinionated, very strong. You buy whole hog into it, you can run your business that way. Now, when you actually deploy your containers to OpenShift or Kubernetes, you need something called a deployment. Deployment is the actually smallest amount of things that Kubernetes knows about, and as you can see, you can have n number of containers in deployments, and you have multiple different deployments across everything. Now, when you have everything together, nodes are actually run Kubernetes. But as a downstream user, you don't know what a node is. All a node is a CPU. The easiest way to think about Kubernetes is all it is an API to compute. Internal concepts of Kubernetes and OpenShift. Need to breathe. Yeah. Because, I was off. There we go. Because we all love DNS, Kubernetes has its own fucking DNS. It's called kubedns. This is a very simple description of a spec to point anything looking for foo-web to point 80 to these services sitting here on port 5000. Namespaces. This is actually where Kubernetes comes into really cool places. This is a way to isolate, put a fence around your application. My application, your application are exactly the same and they can't talk. Not 100% true now, but it is very important to know. On the OpenShift side, they've actually ramped up namespaces to projects where it actually gives you real RBAC on top of it. I've actually seen people integrate Active Directory to talk to different projects, and you can use them ephemerally. Load balancers. There's a way you need to talk into Kubernetes. They actually have a built-in load balancer system. That can be its own talk, but know that it exists. No. There we go. The hardest concept to understand inside of Kubernetes is something called the ingress. Ingress is a way to actually map everything together to be able to talk from point A to point B and how Kubernetes knows about where everything is. But on the OpenShift side, they've taken all that stuff away and made something called a route, which is actually only 2 commands. Instead of writing a bunch of YAML to do all this work, now it's literally route, expose port, expose service, and you're done. Routes are awesome. They make life so much easier for the downstream user. So let's talk about actually how to talk to Kubernetes. You'll know kubectl, or kubectl, however you want to say it. That's your main interface into Kubernetes. It is a powerful application. We all know and love it. Next, we have OC. OC is actually just wrapped around kubectl with all the stuff that needs to talk to OpenShift. It also allows you to do the logging, creating the projects, and all that. OC, surprisingly, is not actually inside upstream software. You have to download directly from the system. What about Helmer Operators? Have you ever heard these terms? Well, that's actually how you just, that's very bright. You need to install applications onto your clusters. You can either use Helm, which does charts, or Operators, which is a little application that checks the health of your system. Linkerd or Istio, that is something called a service mesh. That is longer than 15 seconds I can talk about, but service meshes you will eventually get to because that is the only way you can run your systems in production now. And I think I'm done. Thank you.